Hello, geometry students. It is day 3. We're doing another day of proving triangles similar, but we take it one step further. So you'll see that the prove step looks a little bit different, right, than it looked in yesterday's notes. So if you look at what you're trying to show here, you're trying to show that side AE is to side CE as BE is to DE. Well, all those are the corresponding sides of these little similar triangles. So our goal when we see this as a final prove step is going to be to actually prove the triangles similar first, right? And so the triangles that would make sense here would be the little triangle on top, the triangle on the bottom. So I'm going to call it triangle AEB. If we can show that similar to the one at the bottom, and now keep in mind, if I went A, E, B, this one should go C, E, D. That order really has to be consistent and should make sense. All right. So those are what we're going to prove first. And then we can say this. Which is going to require a new step. And we'll show it in the proof itself. All right, so let me slide this up just a little bit. You should have plenty of space here. Give yourself a little statements and reasons column. Or just S and R if you want to shorthand a little bit. Just like we always would. Let's start with the very first given. So we have AB is parallel to DC, and that is given. And AB parallel to this guy. What we did almost an identical proof in yesterday's notes. So anytime you have parallel lines, think about all the different types of angles you could get. Based on this picture here, if I kind of take a look, there's that nice Z shape. I've got alternate interiors right there. So I can say that angle B is congruent to angle D because parallel lines implies congruent alternate interior angles. And then I have a choice. I can either use the vertical angles or something a little different that we didn't do in yesterday's notes was just to look at the Z in a backward shape. And here, same parallel lines, different pair of alternate interior angles. So I could say angle A is congruent to angle C, exact same reasoning. So I can put that right into step 2. Right, if I look, here's one pair of angles, here's a second pair of angles. Right there, we've got our goal step. We can prove that triangle AEB is similar to triangle CED by angle similarity. And then the last part of it, once the triangles are congruent, what we are allowed to say is that these sides are now proportional or have created a proportion. So I'm going to say that AE is to CE as BE is to DE. And then the way we're going to say this over here is think about what we proved. We proved similar triangles. So similar triangles implies, and then what we're showing is a proportion here. So we're going to show that corresponding sides are proportional. Right? And that is the new step. So since I referenced to it up above, just want to make that clear. Here is the new step. That's one beyond what we did yesterday. All right, let's see if we can try that one more time. So sliding on down here, we are given that we have this diagram here and BC is parallel to DE. Now, I know you can already start to picture where those parallel lines will take you, but think about what we're trying to prove. If what we ultimately want are proportional parts, then our goal has to be similar triangles. That's what will get us to this. All right, so not congruent triangles, but similar triangles. That's what you'd be looking for. All right. And when you look at the picture, it's saying AD is to AB. Well, AD is to this longer side AB, as DE, this, is to BC, this. So it's showing this little triangle, and then similar to this larger triangle here. So what I would say is triangle ADE. If we can show that similar to ABC, that should do it. So when you set your goal, at the very least, know it's similar triangles, but I think it's helpful to actually state which triangles, because then you're set and ready to go when you hit that part later in the proof. All right, parallel lines here. Because of the shape of the diagram, we don't have the Z going on, but we do have our corresponding angles. So I can say that like angle B is congruent to, maybe I'll call that angle 1, because angle D is not specific enough. There's multiple angles there. And that would be congruent corresponding angles. And then just like the proof above it, if we want to make things a little bit easier, we can use the other pair of congruent corresponding angles. That would be angle C down here and angle E right here. So we can say that angle C is congruent to, oops, not angle E. There's two angles right there that could both be angle E. So I'll call that angle 2. All right, either way, they count as corresponding angles. So there's two pairs of angles right there, all with just one reason of parallel lines gives us congruent corresponding angles. All right, on to the triangles. So this is where our goal step comes in. Triangle ADE is now similar to triangle ABC because angle similarity does it. So two pairs of congruent angles will give us those triangles being similar. And then finally, now we can say that the ratio of side AD to AB would be the same as DE to BC. And our reason, just like last time, similar triangles implies that the corresponding sides are proportional. Right? So it's very similar to kind of like a CPCTC. That one says the corresponding sides of congruent triangles are congruent. Here we'd be saying the corresponding sides of similar triangles are proportional. So I'm sure there's some mashup of letters we could fake, but I think it's easier just to kind of stick to using the words here. All right, we only have one or two more. We're going to do one more together and then save one, I think, for class. So let's take a look at what we've got here. So maybe let's take a look at number 3 together, and then we can save 4 for class. So last one in our notes here. Go ahead and get it all good and set up. So statements, reasons. If we take a look at this. Oh, this one looks a little crafty here. We've got congruent segments, which means you could be working towards congruent triangles, but maybe we'll have to use those differently here. And then we've got some perpendicular segments. Either way, my goal step can kind of sneak it in before that. If I want to show that FC, so FC is to DB, I'm going to kind of color code this here a little bit. All right, as AC is to PB. All right, now I can kind of start to see what's going on. In case you're like, I don't see it yet, start connecting the dots. In the blue, I went F, C, and then to A. Connect A all the way back to F. There's one triangle. So FCA. All right, so that's kind of if I put this together. And then the other triangle, I went from D to B and then P to B. So connect from D all the way up to P. And that was kind of the letters put together by that bottom, or the triangle put together with those bottom letters. Said that a little backwards. So that would be what? DBP. Okay. And if in your goal statement, if it turns out you set up the order of the letters wrong, you can always fix it. Not a big deal. Right. So with that in mind, keep in mind that's our focus here. So when it says that AB is congruent to AC, I'm thinking we got to be able to use that in some sort of crafty manner. While I'm at it, I'm just going to put the second given in there. So AF perpendicular to BC and PD perpendicular to AB. So all those givens, feel free to put together. Okay, let's see what we can do. So AB is congruent to AC. So AB, that's this big guy here, and AC. Ah, all right. So AC is in one of the triangles, AB is not. But if I can kind of refocus my eyes, what I really have, I have a single triangle, ABC, where this side's congruent to that one. And if the sides are congruent, then what I'm really looking at is an isosceles triangle. So let's use that to our advantage. So I can say here that triangle ABC is isosceles with base BC. And that's because two congruent sides implies, whoops, an isosceles triangle. And I'm hoping that you're thinking a step ahead. Why do we care about this? Well, if I have an isosceles triangle, I have congruent base angles because my goal should always be to come back to angles. If we've got similar triangles, that's where we need to go with it. So here I called them B and C. In this picture, I might need to be more specific. So B is fine. C is not quite. There's multiple things going on there. So maybe I'm just going to go with 1 and 2, make life a little easier. So those angles are now congruent. So step 3, angle 1 is congruent to angle 2, and that is because isosceles triangles implies 2 congruent base angles. Now, I did not take the time to redraw the diagrams, but if you look, angle 1 is in the red triangle, angle 2 is in the blue. So that gets us a pair of corresponding angles congruent. Now what we need is a second pair, and that's where the other givens come in play. We've got perpendicular lines. So AF is perpendicular to BC, and then PD is perpendicular to AB. All right. It takes a few steps, but we know how to do it. Perpendicular lines implies that we have right angles. And so over here, I'm going to make that angle 3 and make that one angle 4. Feel free to use the letters. It'd be AFC and BDP. Otherwise, angle 3 and angle 4 are right angles. And I only care about those ones because those are the ones inside the triangles. All right. And if they are right angles, they are simply congruent to each other. So right angles implies congruent angles. There's my second pair of corresponding angles congruent. All right, that's enough to get us to our goal step. So step 6 is going to be to say that triangle FCA is similar to triangle DBP, and that's by angle similarity. All right, and then the newest step, we want to finish with our proof step. FC is to DB as AC is to PB. And then over here, practice this. Similar triangles implies corresponding sides are proportional. And keep in mind that we say sides and not parts because the angles aren't proportional. They're congruent. So yes, they're in a proportion of 1 to 1, but we really want to say congruent there. It's specifically that the sides themselves are the proportional pieces. All right, awesome. Number 4, we will save for class. Make sure you've answered the questions. And I will talk to you guys soon. Thanks.